Dear colleagues, thank you for coming. Dear organizer, thank you for the invitation to this perfect event. My name is Sergey, Gordeychik. I never try to pronounce it good morning. I'm very Russian, living here in UAE, also giving lectures in Harvard Space University in Spain. And for a long time I do cybersecurity professionally and also as a hobby. I work in different companies like Kaspersky Lab, Positive Technologies, etc. One of my hobbies is do industrial control system security, so create a cyber-physical disaster, and you can see the demonstration of what is cyber-physical attack on this short video. Important disclaimer, this is my personal talk, not about my job, nothing related to my employees. Before the beginning, I would like to tell you a story. It was several years ago, like 5 years ago. I did a penetration testing a lot, and we got a customer who asked us to do security assessment of the AI-powered CCTV system. So it was like very fresh and very scary because we have zero clue about what is AI like its CCTV system. We call this project Big Bravo CCTV and start like initial discovery, and we found a cool thing, adversarial example. Alex already told about this. So what is adversarial example is if you can change the input to fool the classifier. Yeah, so if the classifier believes this is banana, you can add sticker, and classifier will believe that this is actually toaster. Yeah, and part of our team, we start discovering how to build these adversarial examples for the video system, how to create additional images which will spoof the classification. As you can see in this video, the guy who have a special image on his body, he's not a person, he's invisible man. And if you transfer this picture to his body, the body also become an invisible man. So it's good, it's fresh. Let's say that like if he he's a person, yeah. And part of our team started to do this research to understand how to build adversarial examples for video, but other part, like let's say, old school hackers said, okay, let's be professional. We should analyze all threat models starting from physical security. And we started from physical security. We took a credit card and able to get access to one of facilities where the system is installed. And we found that actually several CCTV cameras, which IP cameras, have very weak, let's say, physical security, so we can cut the cable, connect to RG45, and get access to IP network, and next actually hack everything because everyone thought that this should be secure because this is a dedicated building, you know. And what I want to highlight with this beginning, but AI and AI security is not spherical code traveling in the vacuum. Still, all the problems we have in the cyber are there, but now we have additional layer to protect. Let's try to discuss it. First, let's discuss what is cyber in general. Yeah, everyone here professional. All we know what is holy CIA Trinity, confidentiality, integrity, availability, and this is our goal to make the system which follow this CIA baseline. But in the previous life, I used to work a lot on the industrial cybersecurity, and in the 2020, something like this, it was a big discussion about that CIA doesn't work for the industrial control system. We should rebuild it, and actually the availability is the key. So confidentiality is not that important, and maybe not important at all, but industrial process and its availability is critically important. And it's also in standards for instance, for smart grid. But now we have new discussion. But for artificial intelligence, the integrity is the key. So, is the key. It's very important. So, if we build AI backend system, we should spend a lot of time trying to understand how to build integrity. It's funny approach, you know, it looks like you trying to have this free items and move it upside down and believe that it's magically give you a result. But I believe that there are like some laws, for instance, law for physics, and if you just moving things and try to rebuild the, I don't know, order, it will give you zero results on this picture. I really like this definition of cyber from James Mackens. He gave a perfect keynote address at the Unix Security Symposium, and his definition is that what is the goal of cybersecurity? It's ensure that systems do the right things even in presence of malicious input. It's clear, defined definition, and I like it before because in one of my research for industrial cybersecurity, I gave some quite similar definition. But cybersecurity is a process to ensure that control objects operate with no dangerous failures, with economic efficiency and reliability under adversarial anthropogenic information influence. So the difference with this, the input is from the human, because human actually are smarter than just random noise. And to protect from random noise, you can use, like, I don't know, codecs or something like this. To protect against humans, you should use human only. And what is dangerous failures, economic efficiency, and reliability if we discuss artificial intelligence? I will give you one example. I'm sorry. Can you start from the beginning? Is it possible? No, for this video. Yeah. Just play it. Sorry. Computers. Can you rewind it to the beginning? Okay, so in this video, you can find it on the YouTube. I'll drop you the link. The robot after some, this play button. Yeah, the beginning. So in this video, this is definitely AI security, but where is malicious input, backward overflow, or our traditional attacks? It's just a situation, where this Android became insane. Thank you. How to approach such kind of problems? We should build a threat model first. What we have from the AI threat models is a very good definition from the Professor Lee. He have three values of the AI security in the threat model. First is data integrity, next is model security, and next implementation security. This approach is very good for research purposes, but when you try to build secure system, you need more details because it doesn't take into account a lot of things which also important for the real system, like cloud environment, privacy, IP protection, such complex things like federated learning, which now is very popular. And I found very good definition, a very good threat model from the NCC group. Sorry for this quality of the picture. You can find it by the link, and also this model, threat model, is in the Microsoft threat modeling tool, so you can download it, take it offline, and do a model of your AI process to understand how this how security can impact. It's a very good starting reference. But first thing is the cloud. Anyway, most of the AI application now built in the cloud, work in the cloud, and we should secure the cloud first. What are the interesting things related to cloud security? First is a new, let's say, type of network is an InfiniBand and software-defined network, which now actually everywhere in the cloud. Next is security of machine learning and GPU servers, because it's like new things and deployed everywhere. And for sure, virtualization and containers. Let's review state of the art of security of these things. For instance, for software-defined network and SD-WAN, it's a lot of discussion in the media, which is such a new magic thing which will help you to build more secure AI-powered network. But if you will do a detailed security assessment of such a system, actually you will find that this, in most cases, is just a Linux with old kernel, with a lot of hard codings and thousands of vulnerabilities. For the last 2 years, we did SD-WAN New Hope project, and we did analysis of the different software-defined network system, and we found that most of the vendors failed to create basic security in their software-defined applications and devices which should protect our data center. You can see that red crosses is actually vulnerabilities discovered during our assessment. Next big thing is security of the servers, of the machine learning servers. And now the big thing in the server security is security of the out-of-band management interfaces like BMC, IPMI, UEFI, etc. A lot of good research is published so far, and following this research, we decided, is it possible to find a machine learning server connected to the internet? We tried to find this something using Shodan or our search engine, and we found one which had a web server on the port 5555. And after some additional research, we found that this actually server which used it to mine bitcoins. In 2019, these guys using GPGPU to mine bitcoins. Very funny because it's actually useless. You will consume more power but get revenue. But still, we continue our research and we found that there are a lot of servers which are available via internet and through the SNMP. You can find the details about these servers, and we found, for instance, DGX1. Anyone here know what is DGX1? DGX1 is like a small box which costs 130,000 USD, which have 8 Tesla V100 on board, and which use it to do machine learning. So it's very expensive thing, and you cannot use it to play a game actually. Yeah, you do use it only for machine learning. And we continue our research, and we found a lot of ways how to find the other DGX server, including DGX2, which actually costs 400,000. And what's interesting, this interface which we found, this is DGX-based board management controller. So this is BMC, this out-of-band management interface. If you can hack it, you will hack actually all the operation system, everything on the top, because it's like level -1. Yeah, so it's start before the kernel is loaded. And also we found what's very funny things. I think that this BMC is based on QCT base board management controller, which actually part of based on the Mega Rack by American Megatrain. So Megatrain, sorry. So actually, when we start to communicate with NVIDIA, we even did not understand who built this BMC for web. They just bought the chip and apply on this board. Second story about very old vulnerability. We did security assessment of the cloud data center, and we found that all BMC have vulnerability from 2013. It's a very old vulnerability which allow you to receive hashes from the BMC. You send specific request, and you get all hashes of all users there, and you can offline brute force it. We send request to the vendor and ask them, guys, why you have vulnerability in 2019? They told, this is not our vulnerability. This vulnerability by design of the IPMI protocol. So, we asked them what to do to protect our servers, to make it secure against this vulnerability. They told us, use complex password. But I still cannot understand how the complex password will help me if attacker can ask for password hash from the my system, and he can have unlimited resources to brute force it offline. Maybe there are additional bugs there, but we're still in the process of the responsible disclosure, so we will release our finding maybe in December on the Congress. Let's see. Another interesting thing is that GPU is actually new CPU. It was a lot of research around the vulnerabilities of modern CPUs like Spectre or other attacks, but there are very few research about GPU vulnerabilities. Very old GPU rootkit, which actually initially was presented in 2008, and Jellyfish was renewed in 2015, and I found one additional research about the side channel attack, because in most cases, if you do machine learning, GPU is very expensive resource, and this is shared research between different, for instance, Dockers. Yeah, and if you can. And you can leak part of memory from one Docker to other. So this idea. But also, we start our research in this area, and we found that some of the modern CPU attacks can be used against GPU. For instance, row hammer, which allow you to change the memory using the read instruction, can be triggered on the GPUs. Here's an example. It's not like a proof of concept. It's just a proof of we can do it because we're able to trigger ECC failures. So by reading memory of the GPU, we actually can overwrite part of the memory, but we cannot execute code yet. Next big thing in the data center is Dockers. Dockers now everywhere, and the problem with Docker that no one care what we have inside of this Docker. We just pull it from the internet and run. Here's an example of the vulnerability in Linux Docker image, which had the empty root password by default, and this vulnerability was found in 2015, fixed it, and next appeared in 2019 again. So, and people just download this Docker, launch it, no problem. Also, a very good project is vulnerable containers.org, and if you go to this project and check security of default containers, for instance, container for TensorFlow, you will find that TensorFlow container official have 12 known vulnerabilities. Just by default, you download it, you have 12 unpatched vulnerabilities, and you should care about it, you should patch it. But who patched the Docker images? Actually, no one, because it's something third party, you know. And next thing is serverless security. I don't want to go into details here, but serverless Lambda functions is very popular in the application development for the machine learning, and it has own specific vulnerabilities. Very good research in this area done by pursec.io. You can find it. There is also tested application. You can try, hack, play around, etc. Next big component of the machine learning is machine learning frameworks. Machine learning frameworks frameworks, it's cool thing. It's help us to build an AI application very quick because we does not care about the data process, about how to, all mathematics behind. Actually, you can just use building block to create your AI model. But the problem with machine learning framework, but most of the machine learning framework are very complex application. Here you can see that the number of line of code and external packages in Caffe, TensorFlow, and PyTorch. You can see that it's very big, and it was a very good research by Ken Lee, who published the way how to, by sending image to the machine learning framework, create remote code execution inside this framework. This just because of the, I guess, GIF file parser or something like this, so just obvious memory management error. But now the industry moved from the framework to the pipelines. Here example, NVIDIA Clara platform, which are machine learning pipelines by NVIDIA, and this create help you to build the everything starting from the data annotation, next to the model training, next to the inference server, so and even visualization. Yeah, so it's like ready to run platform. And what's interesting in such kind of application, but actually this is Frankenstein. So, for instance, NVIDIA Clara platform, it's built on the top of the open source components like DCMDK and DICOM server or PAX system, and all these components have own security weaknesses. But people who build this don't care. You can say here, but if you want to have PAX server, just pull the Docker container from the internet. We did some research of security of such components, and we found that actually there are thousands of vulnerabilities there, and here's the public information about fixed vulnerabilities in medical image processing libraries. As you can see, one of vulnerability allow you to get the content of etc passwd file. So you send the DICOM image, it's processed by the your PAX system, and on the output you have not only image but also content of your etc password. Next interesting thing is new languages. Alexander in his talk already told that, okay, we have semantic basic languages, which like Python, C++, etc., and we have machine learning models. For instance, TensorFlow have own linear model, which called graph files, but these graph files have ability to access to file system to make a network communication and even small additional process. But actually no one cares about security of the machine learning model. It's just downloaded from the internet and run it on the inference server. But it's easy to fix it in the way, like say, traditional malware way, and if you can do it, you will have invisible malware, because no antivirus at the moment process machine learning model files. Is it real? We did some research, but again, it's in responsible disclosure process. We will release this information after. Being a product management professional, I spent a lot of time to understand the data which are applicable for this specific application intelligence system. And I can give you an example. Let's imagine that you going to build the system which will apply a computer vision to satellite images. And you want to cover all the Earth in near real time. What's the problem you will need? First is amount of data. Because to cover all the Earth in near real time, let's say 1 satellite image per minute, you need 1 petabyte of storage. Next, different satellites flying on different orbits. So this information will come to you asynchronous way. Sometimes we have cloud, sometimes we have different angle of the shooting of footage, and you should align with all information, store it somewhere, and process. Again, most of traditional security things doesn't work on the top of this huge amount of data, because again, any antivirus which can process 1 petabyte of data daily, any hashing algorithm you can use to create, I don't know, integrity list of this data, how you will check that this data actually came from satellite, but not from the bad guy. It's a very hard task just to manage this data. But there are also additional things like the privacy of the data collection, especially if you deal with personal information like images, payment information, data integrity, training cycle and model integrity, and protection of our IP. It's also was discussed before. About IP protection, you know, the machine learning model is very expensive toy. If you build the, for instance, medical imaging model, you can spend several millions to make, I don't know, lung cancer detection model. But next, you should ship it to customer. And customer actually sometimes can steal it and use it as own model. How we protect our model in this case? There are thousands of ways to attack our model. It's a very good scientific and practical research of using black box attacks, for instance, by creating student model. So you send in a lot of examples, next understand how the model works, and create own model which works similar as a teacher model. But in practical implementation, at least in my experience, in most cases, you can use bingo, grep, and strings to extract the model, because in most cases, IP is not protected at all. And if the model uses TensorFlow, you can just find the TensorFlow API calls, and you will understand that this Python file, this actually is a model. I don't know how it works, and I don't care, because if I drop the image inside, I will receive my results, and I can use it as a black box. The next problem I want to discuss is how the AI works. And the biggest problem here is nobody knows. Here's an example.
This one has learned to look for printed text in a variety of sizes, colors, and fonts. This is pretty cool, because we never asked the network to look for wrinkles or text or faces. The only labels we provided were at the very last layer. So the only reason the network learned features like text and faces in the middle was to support final decisions at that last layer. For example, the text detector may provide good evidence that a rectangle is in fact a book seen on edge, and detecting many books next to each other might be a good way of detecting a bookcase, which was one of the categories we trained the net to recognize.
So this video about object detection, convolutional neural network, and next guy tried to understand how this network works, and they built this visualization framework which show you how the different neuron activates during the image process. And what we found, but this system can detect printed text, but we never train the system to detect printed text. We only show them books, shelves, etc. But by some reason, neural network decide that it's very good, cool thing to detect printed text. Next, it can be used to classification of the bookshelves or books by itself. So the highlight from here, but actually guys who build the machine learning models, they don't understand what is inside. We just pull out information and believe that if ROC and AUC is good, this is enough. And here is a practical research of the memorization of the neural network. It was done by the team by request of Google. The idea was to check how much information you can extract from the neural network. For instance, we use a spark filter as a reference example and use a lot of email to train this model. And next, try to extract the critical information like the social security numbers, PIN numbers, etc. A small amount of information from this model. And we found, yeah, it's possible. Not always, because the model actually is smaller when training data set, but sometimes it's possible. Also, it's a very interesting research which I think should be can be applied to security. I don't know how, but I believe it can be. It's a research which can extract small part of the neural network. So you have, for instance, the neural network with thousands of layers, and next you can try to find the part of this neural network which is responsible, for instance, for the printed text detection. On the previous example, yeah? So it's not necessary to have thousands of layers, it can be 10 layers which detects only printed text, 10 layers which detects, I don't know, faces, 10 layers which detect is a cat or a dog. And you can extract part of this neural network and use it as dedicated neural networks. So again, we built something, we built a big black box which called like AI, and now we try to understand how it works. It's absolutely insane for me as an engineer, because like being actually a railway engineer in the past, I believe I understand how these things works. Now we don't. Adversarial examples, yeah, it's was discussed thousands of times. It's really booming right now. A lot of people doing research in this area, how to spoof a computer vision algorithm, how to using printing glasses become John Malkovich forever, yeah, because on this image you can see if you, some of algorithm, if you use with specific glasses, will detect you as Mr. Malkovich. Also, I believe that adversarial examples are forever. This very good example, I took it from the MIT lectures about clever hands. Clever hands is a horse actually, and in the beginning of 20th century, it was a like show that owner of this horse thought, okay, this my horse can do math. So you can like ask how many is 2 plus 5, and next the horse starts knocking, and when it's reached 7, it stops, and everybody, wow, cool, yeah, so it can do math. But actually, the horse is very smart. It's just looking at the people, and when they reach with 7, the people say, stop and not that. And the horse understood and stopped. So horse want to find something in our reaction. Actually, the neural network also want to find something in our reaction. Here's a white noise. And this white noise was classified by the Cipher 10 classifier. And you can see that in pink box, the classifier able to catch something. For instance, it's oh, this is cat, this is dog, this is something. And in yellow box, it's require only one stage of the adversarial training to find the airplane layer. So neural network does not think things, it's see what we want from this network to see. And this is important, especially if you try to apply it to security. Here's additional example. It's a real life adversarial example.